Supplemental math videos from Circle Christian School. The law of sines. From navigation to the area of a triangle that just aren't right triangles. That doesn't sound right. I bet I need an editor. The law of sines and cosines are Pythagoras at his best. This is a good page about all the cosine formulas. Again, they have kind of a formula to them. If you kind of look at a little bit of what's happening to the letters, you can kind of figure out, because of Pythagoras, which one you're going to use. Just pick the one that works best. This would be a good page to print out from YouTube. Not sure if you can do that, but hey, you guys know more than I do. If we can't do it, I'll be happy to put it up on as a page on the ELC. I can do that part. I'm going to look for the angle A first, just because, hey, A is kind of the beginning of the alphabet anyway. And I've plugged the numbers all into the proper place here. So my result is that I get cosine A ends up equaling 0.75675. Oops, that's not a 5. Getting ahead of myself here. 56. Make sure it's not number 9, and then a whole bunch of 4s. So I guess they get kind of repeated here. And then I'm just going to use, since I'm looking for an angle, use that second cosine thing to get an angle of 40.8. Then you can either use the law of sines or use one of the other cosines. You can use cosine B and go find what it is, and then that gives you your third angle. What I will tell you to watch out for is that when you put this into your calculator, the top part's pretty good. Just make sure after you do the numerator that you hit enter. So hit enter, and then you're going to hit divide by. But when you do this and you times all those 3 numbers together, you know, times, well, this is always a 2. When you times them together, make sure that they're in the parentheses or your calculator goes a little wacky, doesn't play happy because it sees some order of operation things. So I'm going to do another one where we've got kind of a side scenario happening here, and you just have to pick the right law of cosine, whether you want the standard form or otherwise. I'm going to pick the standard form because I can plug everything in here. We end up with an 81 plus the 144 minus the 18 times the 12, which is 216. Cosine 25, what you have to be careful with here is that all these guys go together. You know, avoid that temptation to take the 144 and minus the 216 to it. So with a little bit of calculator work, you will end up with 29.23, is it 75? I think it is 75. And then you're just going to square root both sides and square root both sides, and you end up with A equals 5.4072. So that means the more simplified of us would, well, we would probably make it 441 here. And I like having a little bit of decimal there and not evening it off because it's not exactly 6 or 5, depending on how you want to round it off to. Okay, and after that you're just going to use something like the law of sines to go find the rest, or you can use another cosine to go find some things in the angle there. Use the alternate form inside here. Another thing I'm going to mention to you is that for all ye who are working trig as your concept, you may want to consider working a lot around the law of sines and the law of cosines to do your trig. Nice, fun, looks like real hard stuff, and it really isn't, because hey, you're following a formula and solving some things inside it. And just because I have the time, I'm going to make a smiley face, and everybody who checks out the smiley face can have 50 extra stars. Good for you. Okay, another fun thing that kind of happens with the law of cosines is Heron's formula for area. Heron of Alexandria actually was running around in Greece the same time that Jesus was doing all his awesome things in Israel. So that's kind of a neat little remarkable fact. He is responsible, he loved doing inventions. His little bit of mathematics has to do with the area of a triangle, working with some square roots. So there were some square root things happening back at that time. His main invention, called an areolipile, lipile, is credited with being the first steam engine, although there was some dude before him that kind of did the same thing too, but isn't quite as credited with it. So for all of you that are kind of still, again, working within the trig here, another thing that you can kind of do is go to the Greek and the physics and the science little connection here, and your project using Heron's area with the triangle here can kind of have a little bit of focus on the areolipile. You can make yourself your own little steam engine. Be kind of interesting. You won't exactly be able to use fire for it, but I'm sure we can find something that is equivalent in heat that can do the thing, like a sterno or something like that. But first we have to find the sides, so I'm just going to take my numbers here. Oh my goodness. I'm going to put them in order just to keep Hadley happy. So we have our 35 plus the 25 over the 2, which I believe equals 82 over 2, which is going to equal 41. Oh, let's pick on somebody. Wesley, you can check me out on my math here. Okay, so what we're going to end up now with is the square root of 41 times 41 minus the 32. Watch, Hadley, I'm keeping it in order. And the 41 minus the 35, and the 41 minus the 25. See, now there's beauty in all this because it's just like real numbers, and I love math when we can just go back to real number kind of stuff. So what we end up with is, let's see, we end up with 41 times 9 times the 6 times the 16. And I'm going to practice again a little bit of mental math here. I notice that I have a 9 and a 16 inside here, which are perfect square roots. So we can bring out the 3 and the 4, which I know I'm going to have a 12 on the outside. 41 and 6 happen to be somewhat prime. Well, the 41 is prime, so let's see what we get here. 6 and a 246. Okay, so that's going to give me a 123 times the 2, and and I really, really want to say 123 is prime, so this may be about where we're at. And of course, we can get a nice little approximate. I'll make my little approximate guys, not the best. Little approximate guys, and we can second square root the 246, times that by the 12, and get a wonderful approximately 188.21 units squared. Heron, cool dude.